A lot of these designs these days with the advanced CAD, you can actually generate what they call organic design, where the structure almost looks like a bone. Basically, the material is only added exactly where it's needed, and it's really interesting that some of the designs you're seeing come out for like motorcycle swing arm frames and other things like that, where it's an organic design and you can't really machine it, or if you did, it would be such a waste of material. With additive, you're only using the material where you need it.
Welcome to Agile Talks. I'm still going to call myself guest host Ryan, and today I'm sitting down with Bob. Bob, how are we doing today?
I'm all right. It's a good day. Beautiful day outside.
Perfect. It's that part of the season where I'd rather be outside than inside, but that's just me. All right, so today we are going to talk about materials, processes in additive manufacturing, 3D printing. Right, these are things that are changing all the time. I know you and I were talking a couple of weeks ago, and you said what's available and possible today wasn't even possible 18 months ago with a lot of stuff. So my question to you, very open-ended, tell me your top 3 to 5 things, you have seen lately that as an engineer, right, once an engineer, always an engineer, that you've thought like, wow, that's awesome, or that's really going to help moving forward.
So, a lot of the filaments in FDM printing, it's been out there a little bit, but it's been onesie twosie stuff. It hasn't been real mainstream, but now it's becoming mainstream. For example, PPS Carbon Fiber or PEEK. There was a few printers that could print that. Now there's a lot more printers that can do it, maybe with some minor modifications. PEEK is very interesting because there's a lot of aerospace and even space applications, and it's not an easy material to machine. So especially smaller structures that are needed, 3D printing actually is coming to the forefront and maybe a first choice over even machining for some geometries. So that's really interesting. For the PPS carbon fiber, it's a very strong material, has a very high heat resistance of over 200 degrees C. And it's even interesting when you even pull it off a print bed, because if you tap it with a wrench or something, it almost sounds like metal. It's kind of cool. It kind of is a confirmation of just how stiff it is. But yeah, so those materials alone, I'm seeing a lot of traction with them being used in real applications, long-term, higher heat applications, straight from the 3D printer. So, also in the SLA side, there's new resins that rival the performance of HDPE. And for those that may not be that familiar with HDPE, it's used in a lot of things like your big 55-gallon drums that you see the chemicals are stored in. You see it, even the boaters on the river will put a sheet of HDPE on the bottom of their boat so that when they glance off a rock, they just slide right off of it and it doesn't damage the aluminum hull. It's a very tough and very slippery plastic. And it's got a lot of uses in many applications. For a resin to have that level of performance is very interesting. And, the SLA prints are very accurate as well. So it's cool to see the new materials coming out for the SLA side as well.
When you think, we can go in reverse. When you think about the SLA aspect of that, or not the SLA, the HDPE, did I nail that? So when you think about that, do you imagine it being used in a specific environment? Do you have any suggestions or any ideas or things that you've observed of where people are using it?
Yeah, HDPE, because it's used for like those chemical storage barrels, like it can be used in a lot of areas where there's going to be some chemical exposure that you wouldn't want to use ABS, for example, or some other materials. So chemical exposure, automotive, heavy equipment, lots of those type of applications where it might see some various chemical exposure to be better protected from that.
All right. So with PEEK specifically, you mentioned that it's almost more, it's optimal to print it versus manufacture it or machine it in any other way. Why? Explain to me, like I'm a 3-year-old. Why?
So PEEK, most of those parts that is needed for space or aerospace, they oftentimes they don't need thousands or hundreds of thousands of those pieces. It's lower quantities. It's maybe not large assemblies. It's actually makes 3D printing almost a first choice, if not the first choice, for many of these applications to make this, because it's cheaper and quicker to have it done in a 3D printer or additive manner than it is to set up a machine, have a bunch of wasted material that gets just thrown on the shop floor because it's very expensive material.
Okay. And then I know prior to us starting this call, you mentioned you were talking a little bit about being able to introduce, I believe it was metallic filament. What can you explain that process and what that looks like and how that would be applicable today and how companies could use it?
So yeah, so not only is there, additive manufacturing for powdered sintered metal, there's also now basically powder infused FDM filament that you can 3D print through almost a regular 3D printer. And then you would put the end product into a kiln and basically melt off the plastic, and you're left with just the metal. And you have a metal part when it's all said and done. It's at about 85-90% the density of what it would be if you machined it. There's still a little bit of less density, but it's a metal part when you're done.
So can you give me an example? So would that be for the, let's say the high mix, low volume? Like that would be ideal for high mix, low volume that someone absolutely still wants it to be a metal part. But it doesn't make sense to create a mold, right? Because the volume is so low, or where do you see that being used?
Yeah, you could use it in what you described, low volume, but you still need a metal part. You can use it for geometries that you just literally can't machine. A lot of these designs these days with the advanced CAD, you can actually generate what they call organic design, where the structure almost looks like a bone, basically. The material is only added exactly where it's needed. And it's really interesting, some of the designs you're seeing come out for like motorcycle swing arm frames and other things like that, where it's an organic design and you can't really machine it, or if you did, it would be such a waste of material. With additive, you're only using the material where you need it, and it's really interesting.
Okay. So anything else that comes to mind that, is it a process? Is it a material? Is it a new material that you see people testing out, but they're still not in production, that you just thought, wow, that's going to be awesome when that comes? Or I hope that comes into play one day.
So, a lot of the more cosmetic stuff with multi-materials, multi-colors, it's really interesting, just how creative people are getting out there. But, there can also be a functional aspect with that as well, with, just basically foolproofing, where things need to go by having them color coded, and you can do it in one print now. You don't have to do multiple prints. They can switch heads and print multiple colors, multiple materials in the same print. So that's really interesting. And there's also the sustainability aspect. There's materials that are more recycled. You can get recycled filament that is a little less carbon footprint. And you can also do eco-friendly that is basically decomposable. And if it's something that you're only going to use for a short amount of time, and you don't need to worry about a really long life of it, you can basically plan on recycling it from the start and not be as wasteful there.
Now, that's pretty cool. Now, one day, wouldn't it be cool if you put seeds in it? And then out of it grows a tree. Yep, there we go. Just brainstorming over here. All right. So Bob, I think that's it. We covered all of the cool new materials. I'll probably do this every so often. If you find something cool, I want you to come and tell me about it and teach me like I'm a child. So everyone who's listening, thank you very much. Bob, thank you. Have a good day.
Thank you. Have a good day.